Hello everyone. Today we will be doing the Woodward Fieser Rule for calculation of the lambda max for various compounds in UV spectra. And by not wasting much of the time, let's move on to the first slide. So in this slide, we will study the types of systems. Okay, so the first type of system is butadiene system. Conjugation is required when you are going to find lambda max for various compounds. So butadiene system, you have two double bonds which are alternate to each other. Like there will be a double bond, then a single bond, then a double bond. So they are in conjugation. Okay, and it is a cyclic system, like there is no ring structure. And here the basic unit is butadiene. Okay, homoannular conjugated double bond. Homoannular means like when the conjugated double bonds are present in the same ring. Okay, so that is known as homoannular, and they should be in conjugation. It shouldn't be like एक double bond कहीं पे है और दूसरा कहीं और पे है. No, it shouldn't be like that. There should be conjugation. Heteroannular conjugated double bond, when the two conjugated double bonds are in different rings. As you can see in the diagrams, different diagrams are given for your better understandings. Okay, so we will be learning the base values of the system in next slide, but you have to keep it in mind that the one that will be having the bigger base value will be preferred. Okay, so for example, homoannular ka base value is 253, while for heteroannular it is 215. Yes, so sometimes what happens in questions, you can see that there will be homoannular also, there will be heteroannular also, but you have to take base value as homoannular because it is more. It is 253, and for heteroannular it is 215. Okay, so you always prefer the larger value. Okay, so you can see in this slide three different cases. Now these cases are of exobond and endobond. The topic of concern here is exobond. You should know how to locate an exobond. So exobond is a bond that is outside the ring but is attached to the ring. Okay, so for example, here in case 1, there is this bond that is outside the ring and is attached to the ring, so this is exobond. And in second system, there is one exobond in ring B for ring A. So like the double bond that is in ring B is exobond for ring A, but it is endo for ring B. Okay, similarly, in the third case, the double bond in ring A is exobond for ring B, while the double bond in ring B is the exo one for ring A. So this is how you locate your exo and endo bonds. Endo bonds are not considered, like there is no further value added in the wavelengths. So we need not to focus on them, but exo bonds are important and you should know how to locate them. Now there are given several values in this chart. The parent value for butadiene system is 217. Homoannular के लिए it is 253, heteroannular it is 215. For your exocyclic again, as I told you, like you should know how to locate it, and if it is there, then for each exocyclic bond you should add 5 in the calculations. Okay, now imagine like for now we have studied that there are two bonds in the conjugation. Okay, now imagine there is a third bond in conjugation, then what you will do, you will be adding 30 in the wavelength calculations. Okay, now again for example there is not 3 but 4 in conjugation, like two double bonds in conjugation will form the base value. Any double bond which is in conjugation and is like there is extension of the conjugation after 2. So for example there is another one, like there are total 3, so you will add 30. If there's four double bonds are there, like there is extension of two double bonds, etc. Right, two extra double bonds are there. Okay, so you will add 30 plus 30 60. ओके, तो जितने डबल बॉन्ड्स बढ़ते जाएंगे उतना 30 आपका ऐड होता जाएगा. बेस वैल्यू विल बी फॉर्म बाय टू डबल बॉन्ड्स, उसके बाद जितने बढ़ते जाएंगे एक एक करके यू विल कीप एडिंग 30. ओके, सो there are again oxochromes, for example, your OR, SR, Cl. If these are attached as ring residues, then उनकी values दे रखी है. You need not to learn the oxochrome values because these values are given in question. And you just remember that alkyl substituent, जो alkyl ring residue होता है, उसका वैल्यू हम 5 ऐड करते हैं फॉर ईच alkyl residue. अब alkyl residue को लोकेट कैसे करते हैं हम रिंग्स में, I will show you with an example in the next slide. Okay. Okay. So now let me explain you how we calculate the number of ring residues. अगर आपको number of ring residues पता चल जाएंगी, you can easily multiply it by 5, and then you can get the value to be added to the lambda max value. Okay. तो सबसे पहले ना क्या करना है, दैट आप ये देखिए कि आपकी जो डबल बॉन्ड्स हैं जितने भी, अब आपको डबल बॉन्ड सिर्फ वो दो नहीं काउंट करने हैं जो बेस वैल्यू बनाएंगे. यू ऑल्सो हैव टू काउंट दोज डबल बॉन्ड्स विच आर इन कॉन्जुगेशन. उनकी एक चेन बना लीजिए एज शोन इन दिस फिगर. मैंने एक चेन बना ली, ठीक है. उस चेन को मैंने मतलब कंसिडर कर लिया, ठीक है. अब क्या हुआ कि अब इस चेन के साथ जितने भी मतलब ब्रांचिंग हो रखी होगी इस चेन के साथ, वो हमारे रिंग रेसिड्यूज हैं. तो ये जहाँ जहाँ मैंने लाइंस बना रखी हैं, दिस दीज आर द ब्रांचिंग्स विद दिस डबल बॉन्ड चेन, है ना. दिस डबल बॉन्ड कॉन्जुगेटेड चेन के साथ जहाँ जहाँ पे ब्रांचिंग है, तो पहली ब्रांचिंग है एट कार्बन 1. देन देयर इज एट कार्बन लास्ट की डबल बॉन्ड जो है उसके साथ भी है. एंड यू कैन सी सेकंड डबल बॉन्ड जो है उसके साथ भी है एक ब्रांच हमारी. तो दिस इज हाउ यू कैन सी द रिंग रेसिड्यूज. ओके, वेरी इजी. ओके, सो मैंने सेम एग्जांपल लिया है. अब रिंग रेसिड्यूज इसके कैलकुलेट मैंने करना आपको बता दिए, ठीक है. अब देखो इसमें क्या है कि अ, हमारे पास दो होम्योन्युलर रिंग्स हैं, राइट. एक और एक हेटेरोन्युलर ऑल्सो वी कैन सी, बट हम होमोएन्युलर लेंगे बिकॉज उसका बेस वैल्यू ज़्यादा रहता है 253, राइट. सो होमोएन्युलर वी कैन टेक द सेकेंड रिंग ऑल्सो, फर्स्ट रिंग ऑल्सो, वो मैटर नहीं करेगा. Okay. So I'm taking the first string as the base value, homoannular, so 253. Ring residues we calculated, and double bond conjugation कितनी बार हुई है? There are two extra double bonds, so 2 into 30, that is 60. And ring residues हमने यहाँ पे देख रखे हैं 1 2 3 4 and 5, right? 5 ring residues. And now exocyclic bonds we have to see. Exocyclic bond, we can see that there in ring 1, one of the double bonds is exocyclic for the second ring. But is there similar case for somewhere else? No, it is not there. So only one exocyclic bond, right? Where it is, where we can look at the exocyclic bond, it is in the first ring, which is actually the endocyclic bond for the first ring, but it is exocyclic for the second ring. Okay, so total value will be 343, and the observed value is 345. Now this unit you can see is actually the nanometers. Okay, 10 to the power minus 6 into 10 to the power minus 3, that is equals to 10 to the power minus 9, which is nanometers. These are some examples that you can test and try. Okay, so first वाला तो बहुत easy है, you can directly see it is heteroannular, तो आपको 215 लेना पड़ेगा. There is one exo bond also, and exo bond is in the first string, which is endo for the first string but exo for the second ring. And ring residues आप जैसे मैंने आपको सिखाया था उस स्लाइड में, वैसे आप देख सकते हैं. देर आर 3 रिंग रेसिड्यूज. इफ़ यू कंसीडर दैट डबल बॉन्डेड वाला चेन, उसके साथ उसके साथ सब्स्टिट्यूएंट हैं, 3 उसमें से ब्रांचिंग्स निकली हुई हैं. सो देर आर 3 रिंग रेसिड्यूज. यू कैन कैलकुलेट द वैल्यू. Okay, in the second example, similarly you have to do everything, but there is one thing that I want to tell, and I have like intentionally put this example here so that आप लोगों को पता चल जाए that if there is a bridge formation between two carbons like this, right? So we have to add 15 extra. In after the calculations we have to add a value of 15 extra because of the strain in the ring. Okay, so this is only there when there is this bridge formation. Okay, so this is how it works. Now let's move to the next slide. So now we will talk about अल्फा बीटा unsaturated carbonyl compounds. uh, इसमें ज़्यादा डिफरेंस नहीं होता है. द थिंग इज दैट द फर्स्ट डबल बॉन्ड इज बॉन्डेड टू अ डबली बॉन्डेड ऑक्सीजन, एंड आफ्टर दैट वी विल हैव अनदर डबल बॉन्ड. तो दो डबल बॉन्ड मिलके एक बेस वैल्यू बनाएंगे, एंड further double bonds will be the conjugated double bonds. एक्सटेंशन, कॉन्जुगेटेड एक्सटेंशन, तो जिसमें हम 30-30 ऐड करते थे. सो सेम ही है पिछले वाले केसेस की तरह, बट द डिफरेंस इज कि बेस वैल्यू विल बी डिफरेंट फॉर डिफरेंट कंडीशंस. फॉर एग्जांपल, when there is a carbonyl group, there is the presence of an X group along with it, CHCOX, RCH2C double bond OX. हमारा जनरल फॉर्मूला is for carbonyl compounds. If X is H, it is aldehyde. If X is alkyl group, then it is ketone. And if it is your OR group, then it is an ester. If it is OH, then it is carboxylic acid. So different cases के लिए different values होती है. And हम generally deal करेंगे with ketone. So 215 will be the value for it. And if the doubly bonded oxygen is on a five-membered ring, then irrespective of the X group, the value will always be, the base value will always be 202 nanometer. So these are different values for the substitution. अच्छा, अब रिंग रेसिड्यू जैसे हम निकालते थे पुराने केसेस में, we used to add 5 5 5 5 5. But in this case, ring residue जो अल्फा कार्बन, the carbon next to the carbon which is attached to, एक तो कार्बन है that is attached to double bond oxygen, उसके next वाला कार्बन is अल्फा कार्बन, उस पे जो substitution होगी that will give the value of 10. उसके नेक्स्ट वाले कार्बन यानी जो बीटा पोजीशन है उस पे जो सब्स्टिट्यूशन होगी दैट विल बी 12. आफ्टर दैट जो जितने भी आएंगे गामा डेल्टा और उसके आगे के जितने भी कार्बन की जो सब्स्टिट्यूशन होगी that will add 18 nanometer to our value. And extended conjugation is 30, and एक्सो बॉन्ड भी होगा यहाँ पे 5 वैल्यू ऐड करूँगा. लेकिन होमो एन्यूलर हम पहले एंडो को कंसीडर नहीं करते थे. यहाँ पे अगर एंडो बॉन्ड्स हैं तो उनको हम 39 वैल्यू ऐड करते हैं. नाउ वी विल लुक एट सम एग्जांपल्स. So these are some examples. So first example में we can see that double bonded oxygen is on a like 5 membered का ring. तो 202, 202 is the base value. Now हमने बोला था like two double bonds will form the base value, right? So ये double bond oxygen and the double bond next to it will form the base value. But the third double bond is the extended conjugation, so it will give us the value of 30 nanometer. So 202 आ गया, 30 आ गया, and after that we will check ring residues. So there is no ring residue at alpha, but beta पे we have one ring residue. So beta value will give 12, and at delta, sorry, gamma, at gamma we have again 1, so it will give us 18. Again at delta it is one ring residue, so again 18. There is one exo bond that is for the that 5 membered ring, but it is an endo bond for 7 membered ring. So this exo bond will be counted and it will give us 5 nanometer value, and total will be 285. Similarly, second example can be seen and you can solve it. Thank you. So thank you and all the best for Woodward Fieser rules. A lot of questions come from this concept in every exam related to spectroscopy in your UG and PG. So I think you will be able to solve the questions now. In order to practice some more questions, you can go look for the book called as Y.R. Sharma and Pavia. The PDFs are available online. You can easily download them and solve the questions there. There are good examples, and all the best.